Okay, so let me go over this again. Probably this will be better. So the Turing machine, let's see what does the Turing machine do. It looks at language which we call it context-free language. That's the PDA. The DFA and FA looks at regular languages. The Turing machine looks at this language which is called context sensitive. It can remember the values at C, it can remember A, the number of A's, number of B's, number of C's, and if I have D, it will be a number of D. It can do a language like this when you have a word followed by the same word. It can remember that we have this type of language. So it can use memory, random access memory, RAM. It can use the computation power, almost unlimited, which can do almost any problem except the NP, non-polynomial problems, very hard to solve, like the exponential e to the power AT. And I always say that all our computers today are built on Turing machine, on Alan Turing machines. The way it works, we have an input. That's our input here. You get the A's, B's, 1, 2, 3, X, Y, Z, whatever you want. And we have a head here. That's read write. If I read this location, here, let's say I would read, here, let's say X. I will read the value X. And I can read it and I can write something in its place. Let's say X. I can scratch it and I make it Y. So that's the purpose of the read-write head. And I have my state machines like my other automata. And this state machine is my control and the processor, and that's my memory. That's basically what it is. So now, as I said, read-write head, I have my cell is X, I read X, and then the head moves from left to right or right to left. So what I would say, let's say here, if I will say read X, yes, so I can read X. So I got now my X is I read, and then after that I say write Y instead of X. So I take this X out, and actually I take it out here, and then I write Y. And once I do that, I can say move the head to the right or to the left after I do the right. So this is my operations. So let me put it back as it was. Okay. So here are my operations. The head at each transition, which means every time step. I read from here. I write in the same place. I change the value. Then I move left or I move right. That's the operation of my Turing machine. Let's see how it works. Assume that at time 0, my input is A, B, A, C, and my head is right here. I'll say read A. So I take this A out. Then I say write K instead. So here at time 0, I take it out. Then I place K, I bring K here. Then I will say move left. Move left, actually, it should not be here, it should be here. Because I was here, I moved here. That's what means move left. So if I take one more step, this is at time 0. I was an A, here now it's K, and my pointer points at B. Then I will say read B. I want to read B from this location here and write F instead. So this is, I bring F from outside, I write it, the value F, and then I move to the right. So this pointer moves right here. So at time 2, this is my system here. Let's see if I have one more. Let's say at time 3, I was at time 1 here, F. Now I have G. I want to read G, read K. I'm sorry, because now this is my pointer. I read K. So I no longer have K and I write G instead. So now I have a G and I move right. Let me do one more time. One more slide. So now I am here, time 4. Okay, so now let me take all these out now. So currently, now I want to do time 5. Time 5. Okay. So at time 4, I wrote C and I put my pointer was here. That's where I was. So let's see now what I want to do. I want at time 5 to write a new item. I will say A, F, G, C. I want to write K here. So I will say time 5. There is nothing to read. We call it read blank. And the blank looks like this. Let me see. I think I have the blank, how it can be. Audio symbol. Blank, blank, blank. Yeah, like this. Yeah. So I say read blank. Here, there is a blank here. Let's see, read the blank. So I take the blank out. So there was a blank here. I take it out now from here. And then I want to write, instead of the blank, write, for example, X. So I take the X here. And then I will say move to the right. Move right. So that's an operation. So now when I go to the right, here also will be a blank. Always when there is nothing written, we call it a blank. Blank means nothing. So I have a blank here. Now, if I want to move my pointer to point here at the first character, what I will do. So let's say my task now. Slide. Duplicate the slide. Let me delete all these. Okay, also delete this. So let me put this up. So if I say my question is move pointer to the first character on left, which means I want to move my right here. Okay, now I know that before I have data, all of these will be blanks. This is blank, this is blank. That's how my data is, blank, blank, blank. When I finish, then I will have blank. So what I will do, here is what I will do. I will say move, I will say read the blank. Oops. Okay, so I read the blank, and then I don't write anything. Okay, read the blank. Why this is not working? I will do this. Search symbol again. Okay, I'll say read the blank, and I kept blank, write blank, and move left. So now I keep the blank, and then I come here. Then that's my first operation. My second operation will be like this. I'll say read X, write X. Okay, keep the X and move left. So I get the X, I read the X, put it back, and then I'm here. Then read C, write C, move left, and I can continue this operation. Save my time. Then after the C, the X. Now read C. Now I'm here. Now I will read G, and I will write G and move left, and then the F, and F, keep it back. So I am here. I read F, read A. Now I will do read A, write A, move to the left. Now I'm here. Now I want my pointer to point at A, finally, right here. So I will say write, read blank, write blank, and move to the right now. So here I was able to rewind my tape and I go back, I go from the end, from the last step here where I got the blank, I move all the way to the front and then I position my pointer right here. So again, this is my input string A, B, A, C. I already mentioned that. These are my blanks, which I talked about in a few minutes ago. These are my blanks. And this is my head, which move either to the left or to the right. So at each operation, I have to move the pointer to the next address or to the previous address. Now, in my automata, this is how my automata looks like. If I am at state Q1, I want to go to state Q2. I will say, if I have an A, I read an A, I replace it with a B, and I move to the left. Or I can read the A, replace it with a B, and move to the right. Either way, I can do that. So let's say, this is my automata. Here is I am at time 1. I will say A, this is my transition. Read, and then write, B, and move to the right. And this is how it was. A, B, now at time 2, I have, instead of this, B, and this is my pointer. This is at state Q2, and that's at state Q1. So this is, again, that's what I have just said. If I will go, now if I have an A, now I have one more A, B, A, C. Oh, that's what I said. Then I said move to the left instead of to the right. I come to the left. That's exactly the same. Instead of going to the right, I will write the A instead of the A here. I write a B, and then I move to the left. Now I can say, okay, if I am at the blank now, and I am at state Q1, I will say read the blank, insert G, and then move to the right. So I am pointing at the blank. So the Turing machine is deterministic. Remember, we have deterministic and non-deterministic automata. Turing machine is always deterministic. It will never be non-deterministic. For example, if I am at Q1, I say read A. If you have A, that's what means. If you have A, read it, write instead B, move to the right. But if you have a B, write D and go to the left, this is okay. That's allowed. That's deterministic, which means every time when I want to read, I could have either A or B. But this one, if I say you are at Q1, if you have an A, write B and then go to the right. Or if you have an A, write D and go to the left. This is not possible. You have to do only one. You cannot do this. A and A here. That's not allowed. And you don't have also lambda transition like the PDA. So the automata, the DFA is deterministic and Turing is deterministic. The non-deterministic, we have the NFA and the PDA. These are just a summary of what we have just said. The no transitions for input symbol C. It's possible that when I am at C here, I don't have any transition for C. It's allowed, which means my Turing machine does not move on C. So if I am right here and I don't have a transition on C, it's okay, but the Q1 will not move. If you have only a C and you don't have transition, you can have that. This is an automata that clears the input. So if I have A, B, A, C, this is what we'll say. If I am Q1, if I have an A, right instead of A, let's say if I was at the beginning, if I am here at Q1, I am here at C. So when I do this, if I have a C, I replace it with a lambda with a blank. and then I move to the left. If I have an A, I put a blank, and then I move it to the left. If I have a B, I replace it with a blank, and I move to the left. Then I come back here. From Q2, I come back to Q1, and I find an A, I write a blank. One more time. And then I move to the left. This is one way of clearing the tape. I've done that a few minutes ago. The Turing machine halts in a state if there is no transition to follow. I don't have any transition, then it stands like this one. If I have a Q1 and I don't have a transition out, it means my automata, my Turing machine will halt and will not move anywhere. Okay, so let's say halting example. I am at C. I am C, but my transition Q1 can read, look for A or B. I don't have A here. I don't have B. Then I stay at Q1. I don't move from Q1. This is called halt. This transition is allowed in DFA, regular DFA. Excuse me. Excuse me. Okay. Here the state, this position, it's allowed in Turing machine. In DFA, it's not allowed because I need a transition. Tell me what am I going to do if I have A or B or C. But this one, going from a final state, if I reach a final state, I'm not allowed to get out of it. So it's not allowed. So that's an interesting state. So if I reach this double circle, which is a final state, I cannot get out of it. So when do I accept an input? If machine halts in an accept state, it halts like here. So I finish all my string at Q1 and I don't have, or like here, sorry. Then it accepts. It rejects if the machine halts in an unaccept state, or if machine enters infinite loop. What is infinite loop? I will show you in a second. In order to accept input, it's necessary to scan all the symbols. I have to finish all the symbols in the string. Like here, if I have this string and I reach B, I am still at final state, but I did not finish my string, so it's not accepted here. I have to finish all the string. So this is an interesting automata here. Accept the language A star. If I am at Q0, I say, and I have A's, many A's. As long as you have A, keep going to the right. If you have a blank, let it blank and go to the left and then end the state if I have all A's. For example, this is the example here. I have A, many A's and a blank. So I keep reading. First A, I got the first A here, and I moved it to the right. So now I am here at A. Then the next step, I read A and I go to the right. The next now, I have to read either A or delta. So I still read the A and I'm here at delta. Now I don't have A, but I have this transition delta. I mean blank. If I get the blank, I can do the blank and move to the left. This is what I will do. So I read the blank from here and go back here. And I am at a final state. This final state, when I read the delta, the blank, I finished my string. Now the end of my string is always a blank. So when I reach a blank, then I'm fine, and I ended up in final state, so my string is accepted, all A's. This is rejection example. If I have A, B, A, the first A will take me here. Now, at this position, I either read A or read a blank, but I don't have A or I don't have blank, so I have to stop. So I will stop right here, as I will show it here. Halt and reject. Why I reject? Because I could not read the last A. I could not read the last A, so it rejects. This is this example, which is A star. This I can do my A star like this.